Here we'll be solving another KTU problem. So this problem is from module 5 of MOS, Civil Engineering. This is from the torsion portion of the module 5. Okay. So this question, it was asked for 6 marks in 2017 December. A solid circular shaft is to transmit 75 kilowatt power at 200 RPM. If the shear stress is not exceeded 50 MPa, find the diameter of the shaft. G is equal to 100 GPa. Okay. So in torsion, basically there are two formulas that you should remember. If you remember these two formulas, you should be able to solve these kind of problems. So first formula is the relation between power and RPM. Okay, power and RPM. So basically power, torque and RPM. So power is nothing but torque into angular velocity. So it's nothing but torque into 2 pi f. F is the frequency. If it is given in RPM, you have to convert T into 2 pi n upon 60, where n is the rotations per minute. So n by 60 is nothing but the frequency. Okay, so 2 pi f. So this formula is written as 2 pi nt upon 60. So this is one formula. So you have to remember that in this formula the power is in watts. Okay, and torque is in Newton meter. So these two things you should remember. All other things doesn't have any. So Newton per meter, this is RPM, rotations per minute. Okay. So so there is a inverse time unit also inside N. Okay. So this is the first formula. So let's use this formula first, so that let's see. Power is given. We know that what is given here is power is given. Power is given as 75 kilowatt. So that means 75 into 1000 watts. Okay. Then what we have, RPM is given, N, it is 200 RPM. So that is given. So these two things is given. That is already we required for this equation. So this is not, N is not, we can find T. Okay. So basically T equal to P times 60 divided by 2 pi N. So this will be equal to 75 times 1000 times 60 divided by 2 into, so pi is 3.14 times N is 200. Okay, so if I take out my calculator here, so we can just calculate this very fast. So 75 times 1000 times 60 divided by 2 times 3.14 times 200. So this gives out to be 3582.8. So this is 3582.8 Newton meter. Okay. So this is same as 3582.8 into 10 raised to 3 Newton millimeter. So this is the first part of the problem. We have solved this. Now, so let me just move this calculator. I think I need the calculator again. So let it be. So let's keep it somewhere here. Now for the second part of the problem, we need the second equation. The second equation is T upon J equal to tau max upon capital R, which is equal to G theta upon L. Okay, so this is the torsion equation. T is a torsion, J is the polar moment of inertia, tau max is the maximum shear stress, R is the radius of the shaft. Okay, so this is applicable for both circular shaft, solid circular shaft and hollow circular shaft. G theta by L, this portion is not required for now. We will use this much portion. Okay, we will be using the first portion. So in this, you have to remember that when you apply this formula, the torsion should be in Newton millimeter. J should be in millimeter raised to 4. shear stress should be in MPa or Newton per millimeter square, and R should be in millimeter. This is the units that you have to use. So if you start using that, T, we know what is the value of T. T is given here, 3582.8 into 10 raised to 3 Newton millimeter. Then tau max is given. Tau max is given as 50 MPa or 50 Newton per millimeter square. So student has to recollect that 1 MPa equal to 1 Newton per mm square. So this is basic. This you should remember always. Okay. Then radius is unknown. This is nothing but diameter by 2. This we have to find. Now polar moment of inertia is for the circular solid circular shaft. It will be pi by 32 d raised to 4. Pi d raised to 4 upon 32 will be the polar moment of inertia. Okay, so this is polar moment of inertia. Okay, so now we will substitute this. So let's say T by tau equal to pi by 32 into d raised to 4. So this is a j will go there, j by r. So 1 by r is nothing but 2 by d. Okay, this is 1 by r, this is j. So I am just rearranging. So this shear will come here. This is shear max will be equal to j will go there. J is pi d raised to 4 upon 32 upon r. 1 by r will be nothing but 2 by d. So this comes out to be pi d cube upon 16 will be equal to tau upon torsion upon maximum shear stress. Okay, so now we just have to substitute values here. The value of torsion is here, 3582.8 into 10 to the power 3 divided by maximum shear stress is 50 equal to pi by 60 into d cube. Okay, now this calculator is a basic calculator, so I cannot use this calculator now. Another calculator. So if I calculate this, if you solve this, I will get the value of d something around 71.45 mm. This is the diameter that you will receive. This is the final answer. So this completes our problem. It's a basic problem. All the problems from this portion, that is torsion portion, we can solve by these two formulas. You have to study these two formulas. The relation between power, RPM, and torsion, or torque, and the power between the torsion equation. Okay, so these two, if you use, is pretty basic algebra that you have to, arithmetic that you have to do. So that's all. This problem is solved. Now we will solve another problem in another video. Thank you for listening.